when we need it here, Jaden, when we're going to graph some stuff and do some stuff, review for the quiz, that kind of thing, we'll call on you. All right, let's see where we at. So 47, 48, 49, definitely talk about here at the end. So anybody have any questions before 47, 48, or 49? Now, it looked to me like I saw some question marks by 19 as I walked around. Part C on 19. Okay. Yeah, I think that's a good one. So let's talk about that. So we got the function tangent x, and it asks about increasing, decrease. So it's nice to know, but you do have the calculators. But again, and we're getting very close to that time where, you know, and to be honest, I guess I would say, and I'll probably tell you before a quiz like that, but, you know, really it's fair game. I mean, the stuff from last year, the stuff that, you know, trig stuff and, you know, exponential log, that stuff's all fair game. But it's not like I'm going to have a quiz on trig or a quiz on exponentials or a quiz on those things. It's just they're going to show up when we start getting into the calculus stuff again. Okay, and those things are going to be part of, working with those functions, be part of the problems. And so it's just important to be able to do that. All right, so tangent has here a pi halves, and then it's got another asymptote over here at 3 pi halves, I believe, and it kind of goes through like that, like so. This would be pi right here, and so forth. Okay, so that's tangent. So I happen, before we do C, I happen to look at that part. It says, where is it increasing? What'd you say? Between 0 and 2 pi, where is it increasing? I think it's what it says. Yeah. It's always increasing, isn't it? Now, we can't include the asymptotes, though, right? But so this came up in their class. Somebody said something about concave down. What is it? So by increasing, do you just mean the parts that are concave up? No, those are two totally different things, right? Concave down and concave up are totally different. That's how it curves. So you can have concave down be increasing, and you can also have concave down be decreasing, right? They're two different things. So this is concave down, then it switches to concave up, but that's increasing. Increasing just means going up, right? So this graph's always increasing, but you can't include the asymptotes. So yeah, you would say 0 to pi halves, and then you would say pi halves to 3 pi halves, and then you would say 3 pi halves to 2 pi, right? This graph is always increasing, but you can't include those asymptotes. Now, I suppose you could say 0 to 2 pi, and then x not equal to pi halves, 3 pi halves, right? And then take those out, and then it's everywhere else. So that would be an option too. Okay. So anyway, that came up in their class, so I thought it'd be worth mentioning. All right. So part C says show using sine and cosine that tangent is an odd function. Very good question, because I'm guessing you could have just went over that or looked in the back or whatever and said, I probably didn't even know that. But listen, odd even function is definitely something you have to be able to do. Okay. Now, and you know, in all these different topics, there are probably some questions that are going to be pretty easy and should be somewhat basic. And then there would be questions I can ask that stretch you a little more and make you do, you know, make you look at it a different way and so forth. And so, you know, you just want to know this as best you can as you go through it, so you can potentially answer those questions. It's not like a memorization thing for everything, you know, that you just have to study and make note cards and read, you know, it's not that kind of thing. We've got to understand the concept as well. So even odd functions, so we talk about symmetry. Okay, so yeah, if I give you a function, you could graph it and you could say tangent is an odd function, it's got origin symmetry, and so yes, that would be fine. If that's all I ask you is tangent an odd or even function explained, you would say, well, when you graph it, it looks like this, and so it's an odd function, it has origin symmetry, that'd be fine. But now this question is different. This question says use sine and cosine to show that it is an odd function. So now that's different. Now you can't just do that with origin symmetry. So now probably the best way to go about this is this stuff we wrote here about odd and even functions. This is an even function right here. Opposites in, opposites out. Now I was looking through my wife's notes as I'm thinking about doing honors advanced math class, and I noticed when she did this with you guys with even odd functions, she did it like this. She said, okay, if you put in x, y to a function, and then you put in negative x, negative y, and if those are equal, then that is an odd function. You put opposites in, you get opposites out, that kind of thing. Okay, so that's one way to do it. It's basically doing the same exact thing. And if you put in xy to a function and put in negative xy to a function, you got the same thing, then it's an even function, that kind of thing. So it's similar, it's very similar to that. We're just using function notation, okay? So if you have an odd function, it's saying if you put in a negative x, you get out the opposite of that. That's an odd function, okay? Now a couple quick examples of that would look like this. So say you had x squared, and you want to show that, prove that, not with a graph, not with symmetry, but prove that that is an even function, then what you would do is put in negative x, and so that would look like this, right? And what's negative x quantity squared equal? X squared. So look at that. You put odds in, you get the same thing out. And so that shows it's an even function, okay? Now, if it comes out that it's not the same or it's not opposite, it's neither one, then it's neither. Okay, do the same thing with x cubed. Okay, x cubed, you have this. If you put in a negative into that function, you get that. And when you simplify negative x cubed, it just comes out this. It's the opposite. You get the opposite. So opposites in, you get opposites out. So therefore, that is an odd function. Well, that's the approach we would take here. So what is tangent x? What's another way to write tangent? Sine over cosine, right? That's what they said. Use sine and cosine. So tangent is sine over cosine. Now, so now let's do this thing with odd even function, right? This is one of the things we put in our notes when we were talking about odd even function. Now, we didn't do a problem exactly like this, but I knew we were going to, so we would run into this here. Okay, so now we put in a negative x into there, would make this into sine negative x and cosine negative x. Now, what kind of a function is sine? I think it's periodic function, whatever, trig function. Odd even, what is it? It's an odd function. Sine has origin symmetry. It's an odd function. So sine negative x is the same as what? Negative sine x, because that's what we were just talking about on the other side. You put opposites in, you get opposites out. So you put a negative x in, you're going to get opposite sine if you put an x in. Opposites in, opposites out. So sine negative x is equivalent to negative sine x. And we did a couple examples like this the other day with like cosine pi 6 and cosine negative pi 6, right? You get the same thing out because it's even, right? So cosine's an even function. So cosine negative x is equal to what? Cosine x. Oh, and look at that. So when you do f of x, you get sine over cosine. When you do f of negative x, you get negative sine over cosine. So therefore, it is an odd function. You got opposite out. So opposites in, opposites out. Means it's okay. So if the question was asking that way, that's how you want to approach it. Okay. Show that x squared is an even function. Put in negative x. You get that. But if the question just says, is the function odd or even, explain why, you can use any of those explanations. So you can do this, or you can just graph it and say, oh, x squared, is it odd or even? Well, here's what I did. I graphed it. That's got y-axis symmetry. It's an even function. Okay, so depending how the question's asked, how you would attack it. Okay? What else? Anything else before 47? Which one? 16? Absolutely. Any single part of that or in particular? C and D, increasing D. Here's the thing. Okay. So on 16, they give you ln x. So let's talk about that. Now, again, because of the fact that we can use our calculators tomorrow, probably not going to ask it quite like this, but might be a more involved function. But as we progress here, and again, you really, from this point forward, should be responsible for it, but we need to know that the ln x graph, and again, all these questions about domain, range, increasing, decreasing, I think are all easier to answer if you have a picture. So knowing that the ln x graph does this, okay? So if you want to make a note card of something, make a note card of this, make a note card of the sine function, make a note card of the cosine function, know what those look like. Right? You want to memorize something, then memorize this, right? E to the x, memorize what that looks like. Okay, that wouldn't be a bad thing. Now, There we go. So once we have that, once we know that, or maybe now you just graph it on your calculator so we can answer a lot of the questions. Natural domain. X, it has to be positive. X has to be positive, right? The only X values we can have are to the right of the Y-axis, so X has to be positive, greater than 0. The range is all reals. It goes, never flattens out completely. It keeps going up and up and up. Where is F increasing? So what do you think? Anybody? Now, we wouldn't want to say everywhere, but everywhere the graph exists, right? So it'd be where X is greater than 0. In the domain, it's everywhere in its domain. So X greater than 0. Now you can say X greater than 0, or you can say 0 to infinity like that. Either one of those would be good. So it's increasing all the time. So the ln X graph is increasing all the time. Does it have any local max or min points? Local max and min, that's like peaks and valleys. Any of those? None of those. Okay. Is it concave up, or where is it concave up? It's never concave up. Never. Okay. Because it's always concave down. So where's it concave down? Same answer. X greater than 0. From 0 to infinity. It's concave down all the time. They didn't ask that, but that's what it means. Does it have any inflection points? What's an inflection point again? Where it switches concavity, right? Switches from concave up to concave down. So if it never is concave up, it's not going to switch, right? It's always concave down. So there aren't any inflection points. And so that might have been one of the questions you had looking at. It's like, wait a minute, it doesn't have any local maximum. It doesn't have any inflection points. It doesn't have any. I mean, so it's a pretty boring function, right? It just kind of goes up and it's curved. Okay. Are there any roots? Here's how I want you to get in the habit of answering that. When it says where on a function, they're talking about the x coordinate. Where? So don't put an ordered pair, don't put 1, 0. I mean, we know the y is 0. We know the y is 0 because that's a root. It's a root. We know the y is 0. So it's redundant to just say that. And besides, if you put an ordered pair and put 0, 1, that looks like an interval. Right now it looks like an interval. And now you're saying it has a root from 0 to 1. I mean, that doesn't make any sense. So when it says where on a graph is something, where's the local max? Where's the inflection point? We say the x coordinate. We just say x equals 1, x equals 1. Okay? So that's, we want to kind of get in that habit of doing that and not giving it as a point. Okay? And it's more than just because the ordered pair gets confusing. You're going to see, we're going to get into multiple graphs, and then if you put an ordered pair, the y value is actually wrong because it's actually a different graph you're talking about. But the x coordinate, if you just give the x coordinate, you're in good shape. So that's another reason we do it. Doesn't make sense until we actually get to that. But, you'll see. Okay? All right, what else? What about 31? What about 7? Is there no part of 7 yet? Questions? Or 6? 7? Like any part of it, all parts? F, I'm thinking of F especially, and E. E and F. I mean, that's what I'm thinking of. Okay, I just have a sense that maybe you think you don't have a question, but you might be thinking of this wrong. So let's go to 7. So you got this Q function that is a 6-degree polynomial, which means what? Right from that. How many humps? 6 roots, possibly 5 humps, maybe 5 humps, might not. It might just look like a parabola, actually. Okay, but it could do this, right? Or it could go down. Either way, right? It could do that. Okay, and they said, is it possible that Q is less than or equal to 11 for all values of x? Is it possible? Now, when you hear Q of x, what do we say when we see the function value? When you see this in an equation, inequality like this, what are you thinking of when you see Q of x? What's coming to mind? Not function, but Just ordered pair. Sort of, but it's just one part of the ordered pair. The y value, the y value. See, when you see q of x in something like this, I want you to think output, 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 y value, right? So when they're saying is it possible q of x is less than or equal to 11, I think that's confusing. Is a function less than or equal to 11, right? I don't get what numbers are less than or equal to 11. So you think of it as an output. It's an output. That's what we're saying. Is the y value, is it possible that all the outputs are less than or equal to 11? Yes or no?
Yes.
Yes. Why?
It can be negative and then it'll go down once it's even on both terms.
You can have a negative leading coefficient, which would make the tails go down, and it's absolutely. So all those values could be less than or equal to 11. Now, jump up to number 6e. Is it possible that that function's less than or equal to 11 all the time? Fifth degree has the tails going opposite, right? So that's got to go from negative infinity to infinity. So there's no way it can be below 11 the whole time. Okay, so this is true. But see, this is the part I think, well, if you guys like their class, I think you may be confused. Is it possible that that is less than or equal to 11? No. Why? Because what, Clark? So what's that mean?
So it can't be less than 11 always because if it can't be positive, it has to. It can't be negative, it has to go up. So it could be less than 11.
If it can't be negative, what can be? What can't be negative?
Because the tails go down, eventually it'll go past negative 11. So since it's the absolute value, we have to.
Okay, the key is getting negative 11 in there. There's two ways that here was what somebody in their class said, which led me to believe that they were thinking about this wrong. And I'm kind of hearing the same thing. But now you might be thinking it right. We're just not communicating clearly with each other here. But if you're thinking that this makes everything positive, so therefore the tails have to point up, that's not quite right. I mean, they would eventually have to point up, but not because of the leading coefficient. That's not why. Okay. So, because that's what some of the other classes they said. Well, the bars are going to turn into positive, which means its leading coefficient is positive, and the tails are going to go up and so forth. What this means, there's two ways to think about it. One way to think about it is go back to that thing I did with x minus the middle, less than or equal to the radius. So this is like q of x minus the middle. So q of x minus 0, so 0 is the middle, and q is your y value now, is less than or equal to 11. So what that means is, so a way of saying this, or what those bars, and this is what I'm teaching in my Algebra 1B class right now, is that when you have this, this actually means this. Right? That's what this actually means. So is it possible that this function, the y value, stay between negative 11 and 11? There's no way, right? They either have to go up or down. So if they go down, they're going to go past negative 11. If they go up, they're going to go past 11, right? So that's one way to think about it. Another way to think about it, though, is this. What can somebody tell me what the graph? Well, let's do a simple one. Jaden, you're going to be up here in a minute on the graph, so get ready. Let's say that was x squared minus 4. By that? Parabola shifted down 4, right? By that? Okay. So, what would the absolute value of that? Now, don't graph it yet. Jaden's going to, but nobody else. What would the absolute value of x squared minus 4, what would that graph look like?
Everything below y equals 0 is going to be flipped to positive, so it'll have a hump.
Go ahead and graph it. Everything below, say that again?
Everything below f of x equals 0 is going to be flipped. So like if you have negative 4, you're going to have positive 4 instead.
So you're telling me that if I graph this, it's going to look like that.
Yeah.
Is that what you're saying? Anybody buy that? Excuse me. Jaden? Graph it. Oh, you're looking for absolute value. There it is, ABS. I'll show you another way to get it too. But everybody see where he went? I think he went over to this thing right here, the catalog, the book thing. Had all those things. Okay, go ahead and escape out of there. That's not a bad place to go if you're stuck and not sure. But now you need to get the x squared minus 4 inside there. There you go. Okay, there's another way to do absolute value, which I'll show you. Hit enter. Nicely done. Okay? Nicely done. There it is. So, interesting. But it makes sense, doesn't it? Because what are we saying? We're saying the y values all turn positive. See, so that's why I want you to think about outputs here. So what this is going to do is going to take all the y values and it's going to turn them positive. Now, if they're already positive, they'll stay positive, right? So anything that's above the x-axis is already a positive y value, so it'll just stay positive. But anything that's below the x-axis that's negative, just going to flip up. So that's a great lesson for the rest of this year. If we ever get a function inside of bars, don't try to think of v-graphs like somebody in the other class, I won't mention Sam Stark's name, but he said, so I asked him and I said, what's going to happen? He says, I got this, and I handed him the thing so he could try to draw it, and he just drew a v-graph. Like every time you see an absolute value, it's a v-graph. Well, you know what's happening? Y is absolute value of x. Y is absolute value of x. A v-graph based on what we just learned. Well, pretend the bars weren't there. What do you got? You got that, right? Well, now take everything that's below the x-axis and do what with it? Flip it up. Becomes positive. And that's why you get a v-graph, right? So it's the same thing applies. So you have any function inside of bars, just pretend the bars aren't there, graph that function, and then, this was if there's no calculator, but it's a calculator, check this graph with the bar. But if it's no calculator, just take the function that's inside there, which we all could draw x squared minus 4, hopefully, just shift down x squared, and then take whatever's below, flip it up, and you get it, right? So we can handle any kind of absolute value situation. All right, so what this is saying is that anything that's below is going to have to flip up, so if the arrows were already pointing up, there's no way it stays below 11. If the arrows are pointing down, they're going to have to flip up. And that might be what some of you were thinking. If the bars are pointing down, or the arrows are pointing down, you're going to have to flip them up, and then they're going to go up past 11. And so either one. Okay, that can't be true. But it's a good little lesson in just the bars and how they affect the graph. Okay? All right. So, was that it on that one? That was kind of all I was thinking of. All right. Well, let's go to 47. Oh, what about 31? Jaden, graph this one for us. So, some people came in this morning, and the question was, are we going to have to be able to do this without a calculator? Now, in this next quiz, we get to use a calculator. So, if I ask you domain and range in this, and you get to draw the graph, that's fine. Now, here's what I would caution you, though. So, if Jaden and anybody else want to graph this, go ahead. Maybe you did already. So, we want to do the domain on this one. Okay, and the range. Now, the problem with the calculator, oftentimes, this is why even if you have the calculator, it's good to know about these basic functions and know about these things without the calculator, because the calculator will lie to you. Okay, so he's went ahead and graphed this. Okay, so you graph this function right here. Now, here's the problem. What window do you have? Okay, if you start with a standard window, what I would typically do, unless I've been given a window to try, or maybe it's obvious in the situation what I should do with the window, then I probably am going to go to Window, Zoom Standard, number 5. I'm probably just going to start with a standard window, which takes me to, no, hit Escape. Hit Escape. Just hit Window, Zoom, Zoom, and 5. Okay, and there's a standard window. Okay, now, it looks like, you can see this graph, but you know what you don't know? You don't know if this graph comes down here and comes back over here. Like if we were going to say, what are the roots? What are the roots of this function? Where's across the x-axis? Well, there. But how do you know? How do you know it doesn't come back up here? And this one, look at this. This looks to me like it might be coming, and it might just go right back down. Maybe. You know, I don't know. You know, I kind of know ln x, and ln x kind of does this leveling off thing, so maybe ln x cubed does the same thing. So maybe this kind of looks like the natural log graph, so maybe I'm fairly convinced that's what it is. But you don't know. Sometimes you don't know. And so it's worrisome to you know, think that's it. Now maybe you could zoom out, zoom out, zoom out, and then you might convince yourself, and that's possible too. But if you know something about natural log, you say, okay, I remember that natural log has to be positive. The inputs have to be positive. That means this thing in here has to be what? Positive, right? ln x, and we did this on the one Maddie was asked about earlier, ln x, you have to put in positive x values, right, inside the natural log graph. So that tells me this has to be positive. So I know that x cubed plus 1 has to be positive. So x cubed has to be greater than -1, and cube root both sides. X has to be greater than -1. Okay, now that graph kind of makes sense. So now I'm convinced that, all right, I'm not missing anything over here. This is a vertical asymptote here, kind of like it looks. X has to be greater than -1. Okay, and then Y, and then now your range, so X greater than -1, or you could put -1 to infinity. Okay, and then now this is just plain old natural log from there. So I put in all these different domain, all these different x's that I can, and I'm going to get out my normal natural log outputs, which is all reals. Okay, natural log is just all reals. So it makes sense that that's probably what's happening, and so it all fits with my graph. But sometimes you just don't know. Okay, so you got to kind of be careful. All right.
So with the roots thing, is there anything we can like put in our calculator that will tell us the roots?
It's not going to be an issue today or for tomorrow. Yeah, finding the roots is just finding where the function equals 0. So it's a solve, right? So like if I was going to do, remember this graph we had here a minute ago? This graph here, x squared minus 4, right? This parabola, where does that equal 0? That's an easy one. But if I gave you the function x squared minus 4 and said, where are the roots? You can go, Jaden, why don't you do that for us? Go to your calculator, hit your scratch pad, and let's do a solve. And then, now we're going to do some trig equations here later, not for the quiz tomorrow, but for going forward. Just put x squared minus 4 equals 0, comma x. That's how you find roots, right? That's how you find roots, is do a solve. Set the function equal to 0. So -2 or 2. Now, sometimes you'll get a warning. It'll say more solutions may exist, right? That's where sometimes it's nice to graph it and then kind of see, right? And we're usually not going to do ones where you have a ton of answers, but yeah, there are some things we have to think about when we do those, when we're finding roots. And of course, you can trace. Remember, we showed that on the calculator. When you trace, when you hit the x-axis, it'll say 0. Kind of like when you hit a maximum, it'll say maximum. Okay, but we don't do that often, to be honest. Usually we go in here and we solve if we have to. All right, so let's talk about 47, 48, 49. 47 basically says if you have a graph, that has a horizontal asymptote of y equals 2. Now, interesting note about horizontal asymptotes. You can cross a horizontal asymptote, okay? You can cross a horizontal asymptote. Now, you can't cross a vertical asymptote because that's where a function doesn't define. There is no y value there, so it makes sense if you cross it, there's a y value there, so why do you have vertical asymptote? So you can't cross a vertical asymptote, right? And besides, if you crossed it and came back, then it would fail the vertical line test. It would be a function, right? So, but horizontal asymptotes you can cross, because all the horizontal asymptote is what is this graph approaching way, way, way out here? We don't care back in there what's happening. It's way, way out here or way, way that way. Okay, that's what we care about with horizontal asymptotes. It's out at infinity. That's what's going on. Matter of fact, there's a function, a whole bunch of functions where you can, it looks like a sine graph, but it just gets smaller. The humps just get smaller and smaller and smaller. Well, the y-axis, or excuse me, the x-axis is the horizontal asymptote, y equals 0. It crosses it a whole bunch of times. But the graph, when you go way out there, is getting closer and closer to that, so it's a horizontal asymptote. Okay? Anyway, that didn't really have anything to do with this question. I just understand it's okay to cross a horizontal asymptote. All right, now, so what we're saying is if we shift the graph. So if we shift this graph up 3, where's the horizontal asymptote? Y equals 5, right? Because all those y values that are near 2 are now up near 5. So it goes to y equals 5. Okay, then the part B, we shift it to the left 1. Where's the horizontal asymptote go? It stays there, right? It stays there. It doesn't move. Okay? Doesn't affect it. Okay, and then the last one, we talked about this yesterday, the order of these things. So in C, first thing you do is what to that graph? Which direction? 47C. Which direction? Left 4. Start on the inside, just like order of operations. First thing you do is left 4. Is that going to change that asymptote? It's not going to change it, right? Left 4. Next thing is a stretch of 3. Which way? Horizontal and vertical. It's a vertical stretch. It's on the outside, so it's vertical. Vertical stretch of 3. What's that going to do to that? Y equals 2. Isn't it going to go up to where? 6. right? Think about it, because what a stretch does is it takes all those y values that are over here near 2, all those y values that are near 2, when you stretch it by a 3 factor, now they're near 6. Those values are all around 6, getting close to 6. Okay, so now our line's at y equals 6. And the last thing we do is shift it up 1. Now it's at 7. The order you do it matters, right? The order you do it matters. So it'd be left 4, that wouldn't affect anything. Stretch it by 3, that's going to be up at 6. Shift up 1, now it's at y equals 7. Okay, 48, similar situation, but now you have a vertical asymptote at -3. Is that right? -3. So now what happens if you go up 3? Nothing. All these values that are getting close to -3, getting close to that vertical line, they just go up. So that they're still getting close to -3. What if you shift left 1? Left 1, it's now at -4. This vertical asymptote would now be over here at -4. Okay, what about the next one? You shift it left 4 first, so now it's at -7. -7. Then you stretch it. What's that do? Nothing, right? You got these values that are getting close here. You stretch it. It'll change how close they're getting to it, but eventually they'll get closer and closer. So we shift left, we're at -7. We stretch it. Doesn't affect it at all. It's still at -7. And then we shift it up 1. Doesn't affect it. Still at -7. So x equals -7. All right, 49. Last situation. So let's talk about this. So again, this this problem kind of gets to excuse me. Jaden graphed both these. So first one is x minus 3 over x squared minus 9. And then G graph is, and we had a lot of people with question marks on this one. Okay, so here you got two functions. Now this is a class of functions called rational functions. And I didn't really talk about those yesterday because these are ones we're going to talk about later in chapter 2. We get into limits, we start talking about those kind of things. We get into asymptotes a lot, that kind of thing in there. We'll deal with these kind of functions a lot there. Oops. All right. So we got the f function, g function. Now in part C, this is part A. Actually, a lot of people have questions. Show that f of x is equal to g of x. Now remember what I just said a minute ago, that I want you to think when you see this, think of that as output. That's the key. Right? Output, y values. Show that these y values are the same. When you start plugging numbers, you can start plugging a bunch of numbers, but that's not really the show that they want. They want you to do an algebra 2 kind of show, honors algebra 2. When you had a thing like this, what would you think of? I mean, you're probably just itching to do it, and maybe many of you did it already. What can you do to that thing? What do you mean separate? Okay. More technical mathematical term there would be factor, right? Factor that, right? X squared minus 9, we're going to factor that into x plus 3, x minus 3, because then you can do what? You can cancel the x minus 3. Now, that becomes, so when you cancel those, voila, you get 1 over x plus 3, right? So that becomes, in algebra class, we didn't really care too much. You did a little bit. I know you may not remember this, but you did talk about this, what happens here. But essentially, you simplify that. So what we tend to want to say is those are equal. So f and g are really equal. I just simplified f down. Kind of like 3 plus 4 is the same as 7. You just simplify 3 plus 4 and 7. They're both 7. Well, this is a little different. So you simplify this down, that's fine. But that canceling of the x minus 3 was something happened there. Okay? And so then that's the other part of this question. They say, okay, show that these are equal, except that x equals 3 and -3, right? That's what they're saying there. So yes, this work is your show. This work shows that they're equal right there, okay? Except, what's f of 3? The original f. That's 0. It's 0 over 0, which, yes, is undefined, but it's a really special type of undefined, as we're going to find out here in a minute and later this year especially. That is undefined, but it's a really special type of undefined. Okay, what's g of 3? 1/6. Okay, so see, they're definitely not the same. They're not equal when x is 3. Okay, what's f of -3? negative 6 over 0. Now that's also undefined, but that's a different type of undefined than this, as we're going to see in a minute. What's g of negative 3? 1 over 0, which is also undefined. Now you might be tempted to say those two are equal. Well, 1 over 0, is that equal to negative 6 over 0? Well, actually, it doesn't make sense to use the word equal there because equal compares numbers. Equal compares numbers, and 1 over 0 is not a number. Negative 6 over 0 is not a number. So we can't even compare undefineds using an equals because equals only compares numbers. So that's why f and g are equal everywhere except at those two exercises. That work is your show for part A. Okay, now we talked about domain and range and stuff like that, but now let's move to a graph. So let's graph these two. And you may have done this. Raise your hand if you graphed these when you were doing your own. Okay, you should have. You should have, right? Now I said do some stuff without your calculator, but man, if you didn't understand what was going on, if you're allowed to use your calculator, you've got a function equation, graph it. Put it in. Do something, right? When you don't, one of my favorite lines of all time, when you don't know what to do something. Right? When you don't know what to do something. Because you just never know what that might spark or what that might lead you to. Okay, Jaden, put the other one in the F2. Okay, now, oh, hey, look what he did there. Arrow down. Did you do this on purpose? Arrow down to F2. Or tab or something. Is it frozen? Jaden, where are you at? There you go, right there. Did you uncheck that box?
Yep.
Yeah. See, you can go there with your trackpad. If you put in a couple functions but you don't want to look at all of them, you can uncheck it. But let's check it. Let's put them both on. Okay, so now, there they are. Okay? Hit the tab key and get rid of your thing there. If you just hit tab, it'll get rid of this. There you go. Oops, now it came back. Let's hit it twice. Hit it again. There you go. All right, so now the blue, so look, they look equal, don't they? They look exactly the same. Now, what's going on at negative 3? Let's do a trace. So go ahead and trace. Okay, let me show you a few tricks on trace. Now, you guys, we want to be able to trace on the graph, so it's important for everybody to be able to do. So let's trace at negative 3. So we hit trace, negative 3, look at that, undefined. Tells us undefined. Even puts in like a vertical asymptote. Now, don't be fooled by that. It does that every time it sees undefined. So you'll see here in a second. Okay, so negative 3, they both have, one was 1 over 0, one was negative 6 over 0. We got a vertical asymptote. So they're the same there. Okay, now up, but notice that's in blue. Hang on, yeah, before you put the 3, it hit escape. Get out of that. Ooh, that's okay. Well, we'll get there. Okay, notice how this is in blue right here. Okay, so that's only on the F graph. Okay, do an up arrow. Do an up arrow. Now you see how it's in red? That's how if you've got two graphs on the same screen, you up and down arrow and trace, it'll jump back and forth. So now type in negative 3, and then boom, undefined. Okay, now type 3 into the red graph. So just type a 3, and see there we are. Oh, your float isn't quite set right. Go to your settings, because you should have more decimals than that. Go to settings, number 7 here. Wait, hit escape, hit escape, hit escape, 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 escape. Go to menu, settings, change that to float. So right arrow will go up to plain old float. There you go. Okay, hit enter a couple times. Okay, now you got more decimals here. But that's 1/6. That's 1/6. That's what we said. You put a 3 in, you get 1/6. Okay, now hit the up arrow. Now we're on the blue graph. Look at that. It's undefined. Well, we knew that, right? That's where we had 0 over 0. Remember I said 0 over 0 was a special type of undefined? Is there a vertical asymptote there? There's no vertical asymptote there, right? Now the calculator just puts that in because it's undefined there. There's showing that there's no value there. There's a hole. There's a hole in the graph. Actually, there's a hole in the graph. What this is it's coming down, and there's a hole right there, and then it goes up. Right at that point, there's no value, so it's a hole in the graph. 0 over 0 is a hole in the graph. Any other number over 0 is a vertical asymptote. 0 over 0 is a hole in the graph. Okay, so they're not the same. But you can tell by the graph they're the same everywhere else. They're actually the same at negative 3. They're just not equal. We can't say equal because they're not values. But their graphs are the same everywhere but at 3. Okay, all right. And then domain and range, it's all there. Domain, the red graph would not have negative 3 in it. The blue graph wouldn't have negative 3 or 3, right, in your domain. And then range, what's a range on that? The ranges are the same. What's a range? negative infinity to positive infinity except for 0. There's no value at y0. There's no value when y is 0, okay? It never crosses the x-axis. Those are horizontal asymptotes, which answers a couple other questions. So there's a vertical asymptote here. There's a horizontal asymptote right here. So the negative infinity to infinity except 0, or you can just say negative infinity to 0 and then 0 to infinity, and don't include the numbers, okay? Domain of range. All right, so there you go. Let's talk about the quiz. So that's some stuff with number 49. Okay, so hang on to your calculator there, Jane. You're not quite done. Okay, so I just jotted down a few things. We can just sit here. I don't know how important it is for you guys to write it down. It's totally up to you. I just kind of jotted some things that we talked about here. And so, hello. Sure. As long as you don't take anything. So here's our quiz. Section 1, what did we do in section 1? Piecewise function. Remember when we graphed that? So make sure that you can do that. So earlier I was saying there's some things on the quiz that you can't really study for necessarily. Well, there's certain things, or make a note card for. Well, there's something you want to make sure you review. It's that piecewise function. Number 12 in your homework back on 1.1. I don't have a set of review exercises for you to do here. The book sometimes has some of those, sometimes doesn't, mostly doesn't. It's more a matter of just staying up every day. If you want to go back and revisit some old homework, certainly can do that. But really, studying for the quizzes has more to do with just staying up with things. But I'll try to point out if there's specific things, hey, think about this. That'd be one of them. Well, here's one right here, piecewise function. You're going to have a graph like that with a circle, with a line, that kind of thing, okay? So make sure you do that. Function notation has been a big thing that we've been talking about all week. Domain and range, actually even odd periodic was something I put up there, where it was actually something that was in section 1.1. By the way, we did talk about periodic today, so we've done some stuff about periodic repeating. What was that one question we had where you had a function that had a period of 7? So, right, so if at 0, you get a y of 3, so over at 7, you're going to get a y of 3, and at 14, you're going to get a y of 3, right? Every 7, you're going to repeat the y value. Then we had that one question, what was it? It was like t of 30 subtract t of negative 40, and you were supposed to know what that equaled. Was that what it was? Or?
It was what is t of 30 equal to 10?
Oh, okay. That's basically the same question, but yeah, okay. It was this. It was why is t of 30 equal to t of negative 40? And that was because they're how far apart? They're 70 apart, which is 10 periods. So we don't know what their outputs are. We don't know what their y values are, but we know they have to be equal. So what if, I was thinking it was this, but that must be, I'm thinking of something else. But what would the answer to this be? Same reasoning. What would t of 30 minus t of negative 40 be? 0. Because what did we just say? They're the same. We don't know what they are, but they're the same. So we know t of 30 is equal to t of negative 40, so if you subtract them, you got to get 0. Right? Does that make sense? I mean, that'd just be another way of asking that same question. Another way of asking that same question. Okay? All right. But that was what we talked about with periodic. All right? And then we talked about terminology on graphs, local max, min, inflection points, concave up, concave down, roots, intercepts, increasing. I mean, that's simple stuff. I give you a graph, say, where's it increasing? Like that tangent problem. Where's it increasing? Where's it concave up? You just give an interval, kind of thing. So not going to be a ton of that, probably, but, those are terms that we want to know about graphs. Okay? So I can go back to that if you need that. Need more now. And then this last section was just about the different types of functions. So these are the functions. If we're going to be graphing functions, going to talk about functions, be working with functions, these are the types of functions we're going to be working with. Polynomial, exponential, logarithmic, straight, rational. We saw that rational function, but not so much just on this quiz because you have your calculator. So if it's a trig function or it's a log function, whatever, we'll graph it. We'll answer questions about it. We'll do stuff with it. So, okay. All right, and then, of course, the big one, we're going to do a problem here in a minute, but calculator use. So being able to draw a graph, being able to trace, being able to just use your calculator if you need to. There'll be some problems on here where the calculator's not going to do you any good. You're not going to need it, but somewhere you do. Okay, so let's do this. Jaden and anybody else. I mean, Jaden's our presenter, but anybody else could certainly be. Oh, and then I drew this over here. I don't know why I wrote this over here. I think I'm just reminding, if we have a log type function you put in your calculator, if I give you a window, like sometimes in a problem I might give you a window, but I might not give you a window, and you just have to figure out the window. But if I give you the window, it'll be this way. So there's your X min and max, there's your Y min and max. Make sure you do those. If you have any questions about your calculator, come see me in the morning. Come see me after school, today or in the morning. Just if you're bothered by anything on your calculator. Okay, so let's put in this function right here. Let's do this right here. S of t equals, let's graph this, negative 16t squared plus 96t plus 112. Okay, now, again, because if you have questions about your calculator, like I told you, on a quiz, if you got a question you can ask, but you're not going to like the answer usually. I'm not going to be very helpful. When it comes to your calculator, you need to be able to do those, kind of like the ACT. The proctor's not going to help you. They're not going to answer questions about your calculator. They're not going to, read it for you, whatever. You just have to do your best. And that's kind of how the AP test is. That's kind of how our quizzes are. Now, with that said, if your calculator's really doing something bizarre and it's not really your fault and it's, whatever, then it might. So you could ask. But, for example, so somebody asked, like Caden asked you a question the other day about his graph. It was like this one, wasn't it? It was a lot like this one, wasn't it? And he was asking me a question about this graph, and turned out when he typed it in, he had t's in there. So if all of a sudden on your quiz you just really stuck with this thing, then I might just interrupt the whole class, say, hey everybody, quick reminder, when you draw a graph, you've got to make sure to put x's in, not t's, right? When you go to the graph mode, function mode, put in a graph, you got to have x's, okay? But the function may be given to you with something else. Calculator, you have to put in x's. Okay, so now I might give you a window. I would give you some background. So this would be a problem. I would say, okay, S is a function that tells us the height of a ball. We're going to throw a ball in the air. Now, I might tell you some more stuff. I might tell you that we're going to throw it from a height of 112 feet. I might tell you that we're going to throw it upward with a velocity of 96 feet per second. Now, it's not coincidence that 96 is where it is and the 112 is where it is, because that's what those represent. The height we throw it, the initial velocity. Negative 16 is not coincidence either. That's half of this acceleration of gravity. Gravity is negative 32 feet per second squared, 9.8 if you're in meters, but 32 if you're in feet. So the negative 16 is there for a reason. This is the equation for a ball in free fall, or an object in free fall. So we're going to throw this up in the air. So I give you this scenario. Maybe I tell you some of that stuff, maybe I don't, but I tell you that this is the height of the ball. Okay? And so then I would ask you some questions about it. So the expectation is you would graph this. So Jaden, let's go to your graph. Okay, and then that you would find an appropriate window, probably. Now, his isn't bad. That's better, right? It'd be good to see it. Now, I would hope that when you're going to set this window, you would know ahead of time that this graph should have what shape. When you go to graph it, my hope would be, it's a parabola. It's a polynomial function, degree 2. It's going to be a parabola. Okay, so you would know that. Now, he's experimenting here a little bit with his window. He's got a pretty good window going right there, looks like. Okay, and so maybe I give you a window to use, maybe I don't. If I don't, you're going to have to, play around, zoom out, maybe whatever. But if you know it's a parabola, you probably can get yourself to that point. Okay? Now, I'm going to ask you some questions. So I might say, maybe I didn't tell you the height of the ball or any of that stuff, so I'm just going to tell you. So I might ask, how high was the ball, what height was the ball thrown from? How could you get that from that graph? Trace what? At t equals 0 or x equals 0. So do that. So go on your calculator, menu, trace. He's already there. Okay. Types in a 0, 112. So you'd answer the question. 112 feet, right? You would use units and all that stuff. So this is something I'm going to probably give you is some sort of a problem in context where you may have to use your calculator and then be able to answer some questions using points on that graph. Okay. How high, or how high did the ball get? What was the maximum height? A lot of different ways to ask that. Okay, well, what can you do there? Now, he's there. How do we know that's the max? The other day, didn't it have a little yellow thing that said maximum? it should find it automatically, but is anybody's not finding it? Is anybody's finding it? Anybody get the little yellow thing? In the other class, we had the same issue. Now, and so we came up with a solution. So if that's happening to you, now this is not going to be a big deal to us most of the year, but tomorrow it might be. So do this. You think it's around 3. Type in like 3.01. Just type in 3.01 and hit enter. And now arrow around near there. See, you must have something set. Are you getting the same things he's getting?
I've done that.
Okay, go to trace. Let's all do this, because if everybody else, if some of you are having this problem, yours might be the same thing. Go to trace step. Yeah, it should be on automatic. Okay? All right, hit OK.
Press up on it, it gives me the next.
If you press up. Oh, nice. Okay, so change that back to a 3. Hit the up arrow. Okay, there you go. We learned something else. Okay, try it now. So in the other class, type 3.05. Type 3.05. Now trace back to the left. That's what we did in the other class. We had 3. We went like 3. But we just picked another number somewhere around there, and then we started tracing around. Or maybe zoom in, maybe, and then pick a number around. So if you're not getting that yellow maximus show up, you do some little things. But the up arrow is nice idea. Okay, right. Yes. Yeah, yes. Here's your window is your window would be negative 10 minus 2 to 10. You probably don't need that much negative, so maybe negative 2 to 10. And then let's do it like if you want to see that, you might want to see the x-axis, and then all right. And so now, I can ask a couple things. I can say, how high did the ball get? And then your answer is what? 256 feet. When did the ball get to its highest height? 3 seconds, right? Or whatever the units are, right? So you got to understand what the X stands for, what the Y stands for. When does the ball hit the ground? You're already there? Yeah, you trace. The other one you can trace at, it looks like it's down there around 7. So if you just trace near there, go to 7. Yeah, just type in 7. Hit enter. And if you don't, hit the up arrow. Does that do? Oh, man. That okay. Okay. Too bad that wouldn't get you some bonus points or something. Okay, so there you go. So there it is. Well, clearly you can see it's 0 because you got the 0 right there. So it's 7 seconds it hits the ground. So stuff like that. Be able to make sense of what those numbers are. Okay, last thing, and then we'll talk about some trig real quick, and then give you a little bit of work time here. So the other day, this was another graph. So here would be a situation where it might give you a graph that doesn't have an equation or anything, nothing to trace or whatever. Just have to read off the graph. And this was about an epidemic in a population, and 3 groups of people: those that are susceptible to getting the illness, those that have recovered from the illness, and those that are currently infected. And so I might ask you some questions just to describe what you're seeing on the graph. For example, why is this really high? Well, everybody's susceptible in the beginning. Very few people have it. You know, or how come the infected, what causes after day 13, what causes the number infected to start going down? What's that? Well, more of them that had it are beginning to recover, but why aren't more and more getting it though? I mean, those that had it are beginning to recover, but you know, these people are starting to recover, it's still going up. Why does it start going down? There's not very many people susceptible anymore. So the graphs work together. So once you get up here, look what's happened to the susceptible graph. So in other words, you're in a closed population is kind of the idea. And so all of a sudden, there's not many people left to get it, right? There's not many people that don't have it yet, that kind of thing. And so just be able to maybe read off of a graph and interpret some things from there, okay? That's not really something you study up on really necessarily until you see what the question would be. But just being able to read a graph with units and so forth would be something else. All right, so that's pretty much it for the quiz, right? So a couple things you can specifically study. We talked about maybe looking at domain and range of those basic functions, but you got your calculator, so not a huge issue. The piecewise thing, that's one I told you for sure, right? Be able to do one of those things. So that question number 12 back on that 1.1 homework, you could sure do again, that kind of thing. But so going forward, I want to talk just a bit of trig here. Just do one sample problem for you here. So if we were going to solve this problem between 0 and 2 pi, okay, so we're going to solve this. So our first quiz in chapter 2, for sure, you're going to have to, without a calculator, be able to solve some trig equations, okay? Now, and why is that? Because in calculus, we're not going to do a trig quiz, but in calculus, we're going to be, you'll find out for various reasons, we will be taking equations and we will be setting them equal to 0 a lot. And we'll have to solve those because those will be points of interest to us. And so being able to solve these is going to be something that comes up a lot. Okay? So, and sometimes it'll be a trig equation. So we've got to be able to do it. All right? So not so much tomorrow. So this is kind of a little longer term assignment. Matter of fact, the worksheet I give you and the book problems are really not until Friday. Don't really have to be done until Friday. I'm not going to go around checking them tomorrow. But so first you want to be practice reviewing for the quiz, whatever that means for you. And then, but if you feel you're ready to go, then these would be the things to work on. So what would we do first to solve this, do you think? Do what? Now, that was the first thing the other class said. Man, Ms. Clark must have done a good job of your trig identity stuff. I remember when you guys would do that, you change this to sine over cosine, you cancel cosine. Here's the only problem with that. When you're solving the equation, that's different than when you're simplifying like an identity, right? Like if I have x squared minus 3x equals 0, you could divide both sides by x to cancel, and this would turn into x minus 3 equals 0, and then you get x equals 3. But guess what? There's more solutions than just x equals 3 to this, right? What happened? I lost the solution x equals 0. If you're going to do this in algebra class, what do you do first there? Not cancel an x. What do? You factor out an x, right? So you would factor out, and then you would set each one of those equal to 0. So x is 0 or x is 3, right? So when you divide, whenever you divide or cancel out an x, you lose a solution. You always lose the solution where that bottom would be 0 because that's undefined. So we have to be careful about that. So what we'd actually want to do here is we want to take out a cosine, and that would leave us tangent x minus 1. That's how we would want to do this problem, okay? Now, it's not like you couldn't do that. Jody, you could do sine over cosine, cancel those, but then you'd have to remember, okay, I canceled out cosine, so anytime cosine is 0, I might have a solution there, so you would have to remember that. Because that's what we're going to get right here. We're going to get cosine x is 0, or tangent x minus 1 is 0. So that means tangent has to be a 1, right? Like that, okay? Now, I could turn the tangent into sine and cosine now, but I think I can do it from here. So let's do each one of those. Cosine, where does cosine equal 0? Well, you can do it with unit circle. Cosine is the x or y. Cosine's the x, sine's the y. Cosine is the x. When is the x 0 on the unit circle? Right there and right there. Pi halves, 3 pi halves. Right? That's one way to do it. Another way to do it is to graph the cosine graph. Here's a cosine graph from 0 to 2 pi. Where does that graph equal 0? Here's pi. Here's pi halves. Here's 3 pi halves. Where does that cosine graph equal 0? Where does it have roots? At pi halves and 3 pi halves. I don't care. They're both good ways to do it. So where does cosine equal 0 would be pi halves, 3 pi halves, or in the unit circle, whatever. So there's two solutions right there, which we would have lost if we would have canceled out a cosine and not remembered that. Where does tangent equal 1? Remember, tangent is sine over cosine. So where's sine over cosine going to equal 1? That's going to be when sine and cosine are equal, right? When are sine and cosine equal? Pi fourths and down here in the third quadrant where they're both negative, right? They're both positive here, root 2 and root 2, root 2 over 2 and root 2 over 2. And here they're both negative, root 2 over 2. And so when you divide them, you'll get 1. So it's pi fourths and 5 pi fourths. Okay? So that's just some practice. That's kind of what we're kind of practicing here a little bit. So eventually when we get to that chapter 2 quiz, we kind of know something about these things. So this is really for Friday. I don't know that we're necessarily going to hand it in. I'll probably even tomorrow night, I'll probably even post the answers to the worksheet so you can take a look at those. But it's more for your own benefit of solving. I mean, I may go around Friday and just take, a quick effort grade just based on, what I usually do with homework. But we're not going to, I don't think we're going to hand this in for me to grade. It's going to be for your own. Okay, so the worksheet and then Appendix F 17 through 34. Now, first priority, at some point this evening or whatever, you're reviewing for the quiz, get ready for that. Those things we talked about. Then this for Friday, because then after the quiz, I'm going to give you another little reading assignment after the quiz, but it's not due till Monday. But then Friday, we'll get into a new lesson in the book. And of course, so you'll have that assignment for Monday as well. So getting this done tonight wouldn't be a bad thought, but I'm not going to go around checking. Okay? All right. So you can have the rest of the time to work on those. Now, the first 4 on the worksheet says solve for all values of x. Well, that's when you get into this pi. You get pi halves plus 2 pi n and 3 pi halves plus 2 pi n. Remember that stuff? I'm not going to be big on that, but your calculator, if you try to solve these on your calculator, you get some of that. It's kind of weird. We'll talk about that later, about what your calculator is doing for you. The idea is this would be no calculator, quite honestly. Okay, so those first 4, if you just want to do them from 0 to 2 pi, I'm fine with that. Okay, if you just want to do 0 to 2 pi and not do the 2 pi n stuff, I'm okay with that. And then the last 4, it says 0 to 2 pi. So